Good morning and welcome. So everyone here must be all the people that raised their hand. I'm all new to FHIR, right? So, or most of those, right? So thank you for coming to the general introduction to FHIR. It's a couple minutes early, but I think we can go ahead and get started. So everybody realized we're not in City Side 1, so hopefully we won't have any stragglers over there. So why don't we go ahead and just get started. My name is Richard Ettema. I work for a company called Aegis.net. I'm a lead consultant with that organization. I'm a FHIR certified implementer. So there's a certification program now with FHIR. This was the beta version of that certification program. So I was actually helped out with the beta process of that. And now we have the official one, which I still have to go through to get my official certification. But I've been doing IT for 34 plus years, various industries, but most recently in the last 10 plus years, health IT. And about 5 years now, contributing to the FHIR specification. So I've been around for quite a while doing the FHIR spec. I'm a senior architect, lead developer for our Touchstone FHIR testing platform. So if anybody wants to do testing of your FHIR implementations, we provide a platform for that. I'm also the author of our Aegis Wildfire test server, public test server and client. So if you've been on the FHIR specification site or the wiki, there's a page there that lists all the publicly available test servers and so forth. So you'll find Wildfire under there, so that's my guy. So let's go ahead and just dive right in. What is FHIR? So does everybody here, you know what the acronym is, right? So new standard by HL7 for exchanging health information. The idea for FHIR was to come up with a simplified approach for exchanging health information without sacrificing that information integrity. And at the basis of the specification, we have what's called a resource. And we'll go into that in a little bit more detail about what a resource is, but it's the basic building block of the data within FHIR itself. The screenshot you see here is for the latest current spec, STU3 or R3 as the nomenclature is now. And so we'll be actually taking a look at the FHIR spec page a little bit as well too. But the acronym, if you really want to know what it means, F is for fast, but of course we can't be as fast as we really like. H is for healthcare. I is for interoperable, and R is for those resources, the building blocks. So let's go ahead and take a look at what resources are in terms of the FHIR specification. So everything in FHIR revolves around this idea of resources, the data by which we're going to exchange that information. And the building blocks represent basically the puzzle pieces that we're trying to put together. So we might have something like a diagnostic report. The diagnostic report doesn't live by itself, though. There are references, and it may reference to a patient that's involved in that report. The patient itself may have related persons that are connected to it, so next of kin or so forth. The report itself is probably done at a certain location or facility, and there are probably one or more practitioners that are involved in that report. I asked for a side table, but they didn't give me one, so excuse me. So if you think about resources, what are they? Well, they're the defined structured data elements. So in the specification, when you look at FHIR, you're going to see lists of resources. Now with FHIR STU3 and going on to R4 now pretty soon, there's over 100 different types of resources that FHIR defines. But the idea for a given resource is that the definition of it defines the logical common contents of what that resource represents, what that data collection might be. So they're mapped to various formal definitions. So if you're familiar with other HL7 constructs like the RIM, it can be represented in different formats. JSON and XML are the primary syntaxes or formats that we use. We also have support for Turtle. I don't know if you're familiar with that. It's just another mechanism for organizing the data. It's that terse RDF triple. Yes?
Is the RIM the same here for D3?
Yes. Yeah, so if you actually look in the FHIR specification, the resource itself, there will be mappings to the RIM in the definition itself. So I can show you what that looks like when we get to the website. We have native support for extensions. So what are extensions? Anybody here familiar with V2? Got a couple? So those Z segments, okay? So Z segments in V2 are just extended pieces of information above and beyond what the basic specifications indicates. But in FHIR, they took that concept and they've now embedded it and ingrained it as part of the specification. So the extensions are defined as part of the specification, meaning that if you're going to extend the data, whether it's local, regional, country, might be for an implementation guide in a certain area, the idea is that those extensions, those additional pieces of data are going to be published as part of that implementation guide, and therefore it's part of the specification. So there's a standard way to do extensions with the resources. And of course, human readable narrative is important as well. Anybody here do CDA documents? Okay, a few as well. So you understand the importance of the narrative text within those. Well, FHIR also recognizes that as well. So there is a place to put narrative text in the resource itself. So every resource definition has an area defined where you can define that narrative text. And for FHIR, we do it in XHTML. Okay, so that's the language or the format of that human readable narrative. What you see here, hopefully you can see that, this is a representation of a patient resource in XML format. So the idea is that you have various components here of the structure that are important to understand. Patient, which is the root element here, obviously denotes the resource type. After that, you get some metadata. So you have a resource ID. Don't confuse that with the patient identifiers. This is a FHIR resource ID to uniquely identify it within the context of the repository in which it lives. You have metadata, which could be versioning or last update or tags or other types of pieces of information, whether they be security related or not. And then the narrative text will come right after that. So there's a text element there, and you'll notice that embedded within it is a div where you see the XHTML format. And so why do we use XHTML? Well, the HTML is very expressive in terms of being able to display things, but the XHTML limits the functionality, meaning that you can't put script into it. You don't want your narrative text to be executable. So that's why they limit it to XHTML. After that, you see extensions. So if you have an extension to this resource, they will appear after that. This is just an example from the US core here in the United States, where we have US core birth sex as opposed to the FHIR gender data type. You could do additional, and if you had multiple extensions here, it would just be a list of extensions, one right after the other. After that, you get into what is termed the common data for that particular resource. So for a patient, there is the actual patient identifier. So indicated by identifier with a system, a value, and so forth. After that, we have other pieces like name, address, and so forth. This is not a complete example of all the data elements of a patient, but just to kind of give you a general idea of what the structure looks like. Yes?
So this is considered a FHIR resource?
So this is an instance of a FHIR resource. So you as a patient in some system, this would be the representation of you as a patient in that system.
So a patient is, a particular patient's data is an instance of a FHIR resource?
Correct. So you have a resource. Well, when I say resources, there's a resource type, okay, and then there's an instance of that resource data. So this is an instance of the patient data of type patient.
So that's something like blood pressure?
That would be an observation. Yeah, so various resource types are going to be where you put various types of data. So clinical data is going to be different from identification data, which is different from conformance data, and so on. So, yes?
In an XML resource, what's the potential for XML to drop to XML?
delineated here, so it cannot go outside of that area. So, so the structure itself limits it to only being used within that text element. And it has, well, the div itself as XHTML, yes. I mean, validation engines can go in and validate it. Generally, what you'll be validating is the other element types that you see there. Okay. Yes?
I'm not sure if you're going to cover this, but the difference between the resource identifier up top and the actual patient identifier, is it typical that sometimes those are one and the same, or? I guess
In this case, no, I would not expect them to be. So they could be, but the idea is that you see the identifier is a much more complex data structure, whereas a resource ID is a very simple data value. So, correct. Exactly. So if I have, like I said, conditions, observations, allergies, whatever they might be, patients, they all going to have an ID, that simple ID element with a value to it. And the data type in FHIR is an ID data type, so it has to conform just to the rules of an ID within FHIR, as opposed to the patient identifier. Identifier is another data structure or data type within FHIR, and I can reuse or I can use identifier as a data type across many different resource types, just like the ID can be across many different types. So depending on what you're doing, you may want to have multiple different identifiers, but there's only ever going to be one ID for a resource.
And when you gave that sample, the diagnostic report, that has references to a patient, location, are you using the identifier or the ID?
I would use the ID. So I would use a reference, which would be, it could be a full URL that would reference to another FHIR server or within the same FHIR server to that repository to where I could locate whatever that other resource is, that other resource instance. Okay?
Identifier is like SSN will be one example.
Yeah, SSN, yeah. Mm-hmm. Right, so it's a resource identifier as opposed to a patient. So every resource type has an ID. Not every resource type might have an identifier.
So you're saying any patient resource coming out, or instance of the patient coming out of the system will have the same resource with FHIR identifier, or you have a different?
So I have a FHIR server with a repository with many different instances of resource data. Each one of those instances will have a unique ID, resource ID. And then the patients, the specific group of patients within my repository will have patient identifiers, the identifier data type.
Patient identifier, which I'm trying to talk about this FHIR ID.
Uh-huh.
The FHIR ID coming from our system, let's say from the UK, is sending me a patient information, patient A, B, C. Does the resource, the patient A, B, C will have the same identifier, or is the different identifier of the FHIR ID?
Okay, so across different servers or within the same server?
I'm trying to understand how these FHIR IDs get generated when you say it is just based on the object.
It depends on the FHIR server. So the ID data type could be a UUID generated, so a unique GUID. It could just be a sequentially generated number. Could be a random string following some algorithm within the server itself.
So does the ID uniquely identify a patient, or does the identifier uniquely identify a patient?
Yes.
And are both or either of them durable and consistent across different servers?
So the patient identifier would be the one that would be consistent across. If I had, Richard in hospital A, Richard in hospital B, my patient identifier would be the same, but the resource ID might be different because I'm in different systems.
Would it be durable in a single system?
Yes.
So I could come back with that ID
Yes.
weeks later.
So the reference that I talk about involves the ID. So on that particular server, the ID becomes part of the reference, if that makes sense. Okay?
And it's durable.
Yes. Within the context of the server. Yes. Mm-hmm. So for comparison, if we want to see what a JSON format looks like, there you go. So it's the same data, now just rendered with the little curly braces and square brackets for where you have repeating elements and so forth. A couple key things to note here is that the resource type in JSON, there is no root element in a JSON structure. So they had to come up with a unique attribute within JSON called resource type. So you'll notice that the resource type up there. Now, the difference between JSON and XML is JSON is not as structured, right? Meaning that I can move attributes around, and that's fine. The JSON parsers that we have with FHIR handle all of that very nicely. But I like things ordered, and I like to keep them same order as they are in XML. And actually, the JSON parsers you get as part of the tools within the FHIR spec itself will keep things in the same order as the XML. But that's just give you an idea of what that format looks like. I don't have a turtle example, but you can go look on the FHIR spec to see examples of that as well. So kind of getting into the idea of what types of resources. There have been a couple questions already. Well, what is and what isn't a resource or a type of resource? So for the types of resources in FHIR, in the specification, it actually collects them into various groups: administrative, clinical, infrastructure, conformance, and so forth. So for administrative, or those identifying type of resources, you have patients, you have persons, you have practitioners, organizations, locations. For clinical concepts, allergy intolerances, conditions, encounters, family history, care plan, you can just kind of keep going here. And then infrastructure and conformance, I've starred a couple there because those are relatively important from what I do, and as others in the audience would also agree. Conformance and infrastructure are where you define how your system behaves. So these are resources that allow you to define what your system does or what it's capable of doing. And that becomes very important when you get into testing and into like code generation, that type of thing. Now, what are some non-resource types? Well, if you think about it, things that are very small, like little attributes like gender and so forth. Things that are too big, like electronic health record. Well, those are collections of other different resources kind of brought together into a bundle or a collection. Blood pressure, which I heard, is an observation. It's a specific type of observation, but there is no specific blood pressure resource type because it's just a type of observation. Okay? Intervention, again, think of care plan, think of something bigger in nature is where you have lots of collections of other resource types. So I want to just kind of concentrate on those two infrastructure capability ones that I starred there. Capability statement. As I mentioned, you as a FHIR server developer need to announce to everybody else what your capabilities are. In order for you to be compliant to the FHIR spec, you don't have to implement the whole spec. You just have to state what you do support. And the way you do that is with a capability statement. So there's a special operation that your FHIR server must support, and it will return back a capability statement that will then indicate I support the patient resource, I support operations X, Y, and Z, these search parameters, that type of thing. So the biggest thing here is if you want to declare yourself as a FHIR conformant server or system, you must, at a minimum, provide a capability statement. So you could actually have a capability statement that says you don't do anything else but provide a capability statement and you're still compliant, which is kind of interesting, but that's just what the base spec does allow.
So for a particular resource retrieval, do you have to implement all the retrieval mechanism for a resource if you are just like supporting that resource, for example, patient?
So you probably heard mentioned the Argonaut project.
Yeah.
One of the key aspects of Argonaut is they support the read and search capabilities. So part of their implementation is that they don't do the create and update. At least they haven't defined that part of it in their spec yet. So for their capability statement, if you looked at a capability statement, you would just see read and search as the operations for any given particular resource type.
What I mean is just like in read and search, because most of the elements in a patient resource, for example, like first name, last name, they are all searchable.
Right. So
you can only implement like search by name, but
Exactly. And so search parameters are part of that. So again, if you're going to follow Argonaut, they have a special, they tell you what search parameters you must at a minimum support, right? But you could also support more if you want to. So you could actually, if you wanted to, I just search by identifier, last name, first name. And that might be all that you do. But you put that in your capability statement and say, these are the search parameters that I support.
Is that conformance statement then a query response that you have to?
Yes. So
would like a Swagger documentation be good enough for that, or do you have to?
no. So you have to send back a capability statement. Okay. So the actual resource type of capability statement with its full structure that's compliant to the FHIR specification. Yeah. So if you wanted to, like Swagger, you could probably do things like the API, documentation, but that's not going to be conformant to what FHIR requires. Yes?
The capability that you define, what is the underlying requirement for that? Does it work on the raw HL7, or does it do an ETL from HL7 and go against that repository? What is the typical implementation design for that?
So capability statements can be generated in a number of ways. So if I'm understanding the question correctly, how does a capability statement get built? Okay. So for Wildfire, I build it by hand. Okay. Other servers like, I'm not sure if Happy does this, and for Vonk, I'm not sure. Vonk, you generate your capability statement based on the features that you turn on and off? Yeah. So I have a FHIR author of their Vonk server in the back there. So each server can generate the capability statement according to however they want, as long as the end result is a conformant capability statement.
Yeah, so the reason I asked is like in a typical hospital scenario, you have the same, let's say, patient data or order data or data is coming from different systems.
Mm-hmm.
Each one of them may not have all the fields populated correctly. So
well, now you're getting into the data structure itself. So, now you're getting into those interoperability questions of like, okay, my patient has, I don't know, general practitioner, but over here I don't store that.
Right.
Well, if you're FHIR compliant, you should be able to accept the fact that you have a general practitioner, right? But if you're going to go in the other direction, you don't have it. So this system needs to figure out, do I need to populate it as an optional or is it required? Yeah, so generally what you're going to have when you do that interoperability exchange of data, you're going to agree on a common set of required fields or elements between that between the data.
So FHIR, when you say you're compliant, it doesn't mandate you to say that if, let's say, the middle name of the patient is not there, you send null or...
That would be in an implementation guide. So the base FHIR specification by itself is pretty open. There's a lot of optionality. So if you know your cardinality rules, there's a lot of zeros all over the place. Because the intent is the base FHIR specification is the starting point. So you want to generate implementation guides where you then put further constraints on based on your use cases. Right? So that would be for your exchange of data. Yes?
If we're connecting as a client, but yet writing back, are we considered a server and we have to check for that?
Could you restate that?
If we're connecting to another...
So you're a client.
Yeah, we're getting data and maybe writing some back.
Sure.
Are we just replying to that?
So structure definitions, now that we're on this page, what are they? So a structure definition is a way to describe the rules around the data of a particular resource type. So the base FHIR specification, every resource type has a base profile or structure definition where you get a bunch of zeros for the cardinality, okay? When you get to an implementation guide, when you get to actual use cases that are out there, then you're going to be building structure definitions that extend the base profiles and then add those additional constraints. And those constraints can be simply cardinality rules. I now make it required with a 1. Or I could actually put in logic in the structure definition through expression language to actually do more complex, like, oh, this field is required if this code value is X, type of thing. So, Right, so, and then you would want to announce that you are compliant or conformant to that structure definition. And that's actually part of the metadata in a resource. So we're kind of going far afield here, but yes, that's the idea, is that you want to announce that you support, or the server may be sending you back something where it says, I support profile X. And then you can look at that and go, oh, I support that, good, I'll take it. Oh, I don't support that, I may have to reject and do something else with it. Okay, yeah. So I have a little use case here that kind of demonstrates the use of different FHIR resource types. So this is a pediatrician immunization scenario. So imagine you have a mother who's taking their new child, maybe just a couple months old, let's say, to the pediatrician, and they're doing a follow-up from, after the birth in the hospital, and the pediatrician wants to check to see what immunizations might be due for this child. So this is just a general question. What types of FHIR resources might we use to record the visit and to do that immunization forecast, to go evaluate what immunizations or vaccinations might be needed? Well, for the visit, you can imagine I need a patient, that's my child. I have practitioner, the doctor or pediatrician attending, the organization that that pediatrician belongs to, the location where it's at, observation, which is, the pediatrician's going to be doing measurements and height, weight, and all, kinds of things. An encounter to record the visit. You can imagine even more. Related person for the mother, as next of kin, or whatever. For forecasting the shot, well, this is more of a clinical decision support type of operation that we might do. So now I'm going to take some key data elements about my patient, send them off to a forecasting engine service, and then get back a result. And so there I'm going to have the patient, but I'm going to de-identify the patient in this case, because I don't need all the PII for the patient. I just need gender and date of birth maybe at a minimum. And then I also need immunizations, meaning those vaccinations that have already been administered. And then I'm going to get back from the forecast engine immunization recommendations. And so these would be the vaccinations that are probably due or coming up for the child. So if you think about the workflow process here, I've got the pediatrician's office. They're going to do a forecast request, and this can be a FHIR operation. So I'm going to send patient immunizations as FHIR resource instances to a forecasting service, which has CDC here in the US, has forecasting rules for immunizations. Send that information back in the form of a forecast response, which is the recommendations. And I've actually implemented this using a forecast engine that is a testing environment from a colleague that I worked with a little while ago. And we're actually promoting this as an addition to the FHIR specification. So this is under ballot right now to promote this CDS, Clinical Decision Support Immunization Forecast, there's a mouthful, operation in FHIR. So we're hoping to have that balloted sometime in the very near future. Yes?
Just to tie this use case back to the previous discussion about implementation guides and required fields, you mentioned that you would want to DID the patient before you submit it. In that case, for example, the identification field might not be required for this
Correct.
service, right? It would just be that you said gender and date person.
Yes.
And that would be something that they probably have to find.
Yeah, so I know where you're going, and that's actually what we did. So we made a profile, a structure definition on the patient resource. But in this case, we're now saying that the only two elements that I want in the patient is gender and date of birth. Everything else I don't want, right? So that takes away all of the identification information. We originally actually did this as sending them as two separate data elements, but then we said, well, we have a patient, let's just profile it. Yes?
I'm curious about the rationale behind developing an immunization resource.
You'll probably have to talk to the work group at HL7 who manages that. But there have been some discussions, I know, I've been involved with them because of my involvement with this implementation guide. The immunization resource type and immunization recommendation, there's now an immunization evaluation resource type in R4. So there's been some work to kind of restructure, because you might think of an immunization as an administered medication, right? So I have a medication administration resource. And there's actually harmonization between the two, because they actually wanted to drop immunization and make it a profile on top of medication administration. That didn't quite make it all the way through, and so we're still left with two separate resource types, but they've tried to harmonize them now, make the element names align more closely. So they may still want to try to do that at some point, but that's as far as they've gotten so far. Yes. So good question. Yes.
Sorry, this is a bit more critical, but for me to understand. So you develop the profile, for instance, in that example, you are sending only gender and
date of birth.
And date of birth.
Yes.
So for immunizations, that wouldn't be enough because I need the diagnosis, for example.
Well, that would be a different resource type.
So you will consume the other.
Right. So the patient itself is limited to just those two elements, but now I might have to send along observations or other resources, right, that would help the decision support engine to make a better determination. And that's actually where we're going. Very good point. We are including other resource types that could be in the operation that the decision support engine could work on to evaluate that recommendation. Okay. So this is where I normally do a live demo and actually show you the pretty interface that I've built. I just found out this past weekend that the forecast engine that I keep using has just been upgraded from version 3 to version 4. And I've been on vacation and traveling, and so I haven't had time to update my interface to work with it. So right now I'm getting back a 404 from the service, so it wouldn't make much sense to show it to you right now. But the idea is that once I get that fixed, okay, you can go to my client here. So my Wildfire client GUI interface here, this is publicly available. This is not an EHR, by the way. Okay, my Wildfire client is just for generating FHIR conformant requests. And I have different tools and so forth up there as well, too. Yes? Well, no, this was the API to my forecast engine. Right, so my FHIR server still is compliant to the forecast operation, but my backend call to the actual forecast engine, they changed their interface on me. So now I need to redo my interface to be conformant to them, and then I can be, my FHIR operation will then work again. No. That is only when you're dealing with normative content. So right now, and is everybody familiar with what I just said, normative content? Okay, so the FHIR specification, is it normative? No, it is not normative yet. The FHIR specification is not going to go normative all at once. So the whole spec is not going to be normative all at once. This is a little bit different than maybe V2, V3, and other specs that you're probably familiar with. The concept here is that they're going to take resources that have been matured and tested and move them up into the FHIR maturity model. And I actually talk about that at the very end here. So I'll hold the rest of that till the end. Yes?
You mentioned the interaction with the recommendation service. Is it an operation of the recommendation operation?
So the operation is something new that we're proposing. And so we actually had to come up with a name for it. So I called it CDSI forecast. They've renamed it on me a couple different times. But so there's an operation definition resource. I've got 10 minutes, so I got to get through some more slides. So last question for right now. But there's an operation definition that you define what the new operation is, and so that's actually part of the ballot process as well, too. But you define what your inputs are and your outputs and all that good stuff. One key concept here that I want to get across is that FHIR actually defines how to test FHIR. And this is something near and dear to my heart because I do FHIR testing with our Touchstone platform. So FHIR testing is built into the specification. If you go to the testing.html page, you'll see the definition of what a FHIR test engine should do, what the workflow process is for all that fun stuff. And there's actually a new resource type out there called test script which I've been heavily involved with to actually help define what an executable test case would be from a FHIR perspective. I mentioned those publicly available FHIR servers, so that's just what the wiki page looks like, and there's the URL for it. So it's on the FHIR wiki, and there's like the big title, publicly available FHIR servers for testing. Fortunately, if you go to the FHIR spec homepage, go to the bottom, there's a link that'll take you right there. So you don't have to worry about that too much. But these are all the FHIRs that are publicly maintained by different entities, like myself, Graham Grieve with his, the Vonk server from FHIR-Lee, and so on and so forth. Now, there are different paradigms for interoperability that FHIR supports. And we're going to go through these relatively quickly, just because I'm running out of time. But REST, documents, messages, and servers, or services. Well, REST is kind of what the FHIR spec was based on when it first started. So way back in the annals of history of FHIR, the idea was that they wanted to use more current, modern, up-to-date interoperability paradigms, like the RESTful API. And so this is basically just simple out-of-the-box interoperability using the HTTP methods for get, put, post, delete, and so on. Well, there you get your automatic CRUD operations, create, read, update, delete, but then you can extend those with additional parameters to make other types of operations like history, read version, search, and patch, and so on. And that's all defined quite nicely in the spec. Documents, similar to CDA. So if you're familiar with CDA, it's a collection of various sections, right? Well, those sections are resource types, right? So in FHIR speak, we put them together in what we call a bundle. So bundle is another resource type where its sole purpose is to collect other resource instances within it, okay? Provides a single context so we can sign, we can authenticate, and so on. Messages, similar to V2, V3, that request-response paradigm. So Renee Spronk, I believe, who is here, is going to be giving a talk on FHIR messaging during these couple of days. So if you're interested in the messaging paradigm of FHIR, there is an actual defined structure within the spec about how to do FHIR messaging. So again, using bundles as the payload for the request and the response. Service-oriented architecture, well, this is just a catch-all, meaning that we can collect together all the other paradigms in various workflow paradigm, or complex or simple workflows. Again, we're going to use individual resources or collections, whether they're in bundles or contained or other formats. The idea is that generally you're going to use HTTP, like the RESTful interface, but you're not restricted. You could use secure email, you could use secure socket, whatever it might be. But the main underlying theme here is that you're always passing things around in the FHIR structure, in a FHIR format. So regardless of the paradigm, the content will be the same. So you could have a repository, whether it's natively FHIR or there's a FHIR facade based on an existing data repository. We could receive a lab result through a FHIR message. Those resource types could be disseminated into their individual resource instances within the repository, making them available through RESTful calls to perhaps a device that a physician is carrying on the floor. And we could also do things like collect them back into a document that could be sent off to a national exchange. The FHIR specification, how many people have been to the FHIR spec homepage? Okay, great. So you know what this looks like, right? So this is actually not the FHIR spec page, this is the directory page for all the different FHIR versions that are available out there. So the most current version right now is the 3.0.1. The .1 is because there was a technical correction. Okay? But the current is the CI build. This is the latest, greatest bleeding edge version of FHIR on its way to the next version, which is going to be release 4. Hopefully September, October, I believe, is the ballot. But then you can also get back to the previous versions as well, too. FHIR specification, just some key elements. The resources up at the top there. You've got the RESTful API, data types, and of course, I like testing down there, so I have to keep promoting that. The RESTful API, everything in the FHIR spec, if you've been through it already, you know that everything's linkable, right? So if you go to the RESTful API page, you can click on the update and just drill right down to where the update definition is. If you go to a particular resource definition, like the patient, there are different structures here that tell you how the format is for the resource type itself. Again, everything is linkable. So if you have a data type in FHIR that you're not sure what it means, like human name, well, that human name is a structure itself. So you can click on it and go down to the human name data type page and see what the structure of human name looks like. If you want to get to the data type page itself, then you have this nice pretty diagram here, again, all clickable to the different types of data that FHIR supports, whether they are the primitive data types or the complex data types. And by complex, I just mean it's another structure, okay, like that identifier, like the address, and so on. So the FHIR maturity model, I just want to briefly talk about this. I mentioned it earlier. As you move pieces of the FHIR spec through this maturity model, eventually you're going to get to what's called normative. So you start out with 0 draft, which means somebody had a great idea and put it in the spec and it compiled. Okay? Then people have to start using it, and we can slowly move it up into 1, where there are no warnings in the build of the FHIR spec. And then we get to a connect-a-thon event where people start testing it, and then we get into more formal publications. And then finally, we get into more independent production releases. And eventually, we're going to get to version 6 or release 6. And that means that that piece of the spec is now normative. So what does normative mean then? Well, we heard backwards compatibility. But it's really not backwards compatibility. It's forwards compatibility. Okay, so you have to think in terms of, let's say I have an R4 normative content, like the patient resource is going to go normative. Well, if I go to R5, I know that the R4 will work in R5. I'm not necessarily guaranteed R5 will work against R4 because I could add elements. The structure can still change, but I'm not going to break anything previously if I add something new. So it's forward compatibility rules kick in when you go normative. That this is the FHIR maturity model for the FHIR specification.
Is the same true for resources and other?
Yeah, so various aspects of the specification are going normative. So like the API, the resource types themselves, the search paradigm, there's just different pieces of the spec besides just the resource types. So if you go to the current build of the FHIR spec, you'll see little numbers. Like you see the 3 next to capability statement. In the current CI build, what you'll see is any resource or any part of the spec that is going to go normative for the next release will have a little N next to it. So instead of a number, you'll see an N there. And that's because it's now balloted to be normative in the next version. So recap quickly, we have resources, extensions, different methodologies for putting data together, different syntaxes, human readability, we've got capability statements, profiling with structure definitions, and different paradigms for exchanging data. And again, you've seen the spec, a lot of online documentation. There's a lot to go through there to understand the FHIR spec, so don't expect to learn it all in one day. It's a progression of going through the spec little by little and getting comfortable with it. So from a timeline perspective, as I mentioned, R4 is going to be the first release coming up later this year, which will have normative content within it. Okay. And with that, I think I'm at 0 for my time, so I thank you. If anybody has any other further questions, I'm available, in the breaks and so forth. And I have a testing track that I'm going to be presenting as well today and tomorrow. And I'll be up in the mezzanine at the testing table for the hands-on later on.